Let's take a look at question 2. It says that the variables x and y are connected by the equation y equals to x squared minus 2x minus 1. Part 1. Complete the table for y equals to x squared minus 2x minus 1. We are given the table of x and y values and we're expected to complete it. While all the values of x has been given, not all the y values corresponding has been given. How do we find them? We'll find them by substituting the values of x into the equation to get the corresponding values of y. So, how am I going to do this on a piece of graph paper? Will be this. So, moving on to a piece of graph paper, I actually drew out this table from the question, and this is the equation where I will be substituting individual values of x into in order to find the corresponding values of y. Right. So let me go ahead to attempt this. Excuse me, let me just bring it up higher. Okay, so when x is equals to 1, so I'm going to submit the value of x equals to 1 there. My corresponding value of y will be 1 squared minus 2 bracket 1 minus 1. Okay, and it will be minus 2. So with this value of minus 2, I'll be putting it in here. This is one pair of coordinates that I've got. Now next, I'm going to substitute the value of x equals to 2 inside the equation. So when x is equals to 2, okay, y be 2 squared minus 2 bracket 2 minus 1, and my corresponding value will be minus 1. So I will put in the value of minus 1 here, and I will do the same for x equals to 4. Okay, so now that I have all the values, I have done part 1. Part 2 says, draw the graph of y equals to x squared minus 2x minus 1 for the range of x between minus 2 and 4 inclusive. Okay, so just nice, it starts from minus 2 all the way to 4. So I have to think, hey, how am I going to draw the axis of this, this equation? Before, how do I map it out? So let's take a look at the minimum and maximum points of x. We have minus 2 all the way to 4. So that will dictate where I actually put my y-axis. It will be less negative, more positive. Okay, so perhaps I might want to draw my line somewhere here. Okay, maybe somewhere here. And let me mark out my y-axis. Now, from here this will be where x equals to 0 is. This will be x minus 1, x equals to minus 2, and then there is a bit of buffer. Whereas if I were to move to the right hand side, I will have x equals to 1, 2, 3, 4, and I still have some buffer on the right hand side. Now let's consider the x-axis. How am I going to draw it? And let's take a look at the minimum and maximum values of y. We have minus 2 all the way to 7. So you can see from these minimum and maximum values that it is more positive than negative values. Alright, so let's see. I will probably have to draw my x-axis towards the bottom of the page. perhaps somewhere here. And I will mark out the x-axis. Okay, now this will be my origin. Next, I could put in the values along the x and y axis. Okay, and then moving right. And then now along the y-axis. Okay, now that I'm done, I'm going to start to plot the points that I have over here. So my first point is minus 2, 7. Excuse me, let me just prop this up higher a little so that we can zoom out. Okay, so we have minus 2, 7. How exactly are we going to draw? So hopefully you remember your secondary one plotting of graphs. So minus 2, 7 will be somewhere here. Okay, next one will be minus 1, 2. Minus 1, 2 will be this point. After that, we have 0, minus 1. 0, minus 1 will be this point. Okay, and then subsequently, we have 1, minus 2. 1 minus 2 will be at this point. Moving on. 2 minus 1. What you notice from here is that, hey, I have the same value of y for these 2 points. So this could tell us that actually this along x equals to 1, this is the turning point. This is the lowest point of the graph. Okay, because for quadratic, it will be a parabola. That means there will be one line of symmetry along x equals to something. Okay, so next point will be 3, 3, 2. Here, and finally we have 4, 7. So let me just plot the last point. This will be the last point. Okay, and now comes the part where we have to draw the graph. And as you know, this is a quadratic, so we will have to draw the quadratic curve. Yep. So let's see how this will turn out. From secondary 2, you would have learned how to draw a quadratic curve based on the curve ruler. Not the easiest thing to do, right? Not the most pleasant thing to do. We try. to the left hand side. Okay, now I'll be looking for portions that I want to even out to make the curve look better. So here, I will have to even it out. Okay, here isn't too impressive as well. But at least by doing one draft, a rough one rather, it gives me a good idea of how the graph will look like, and then I will try to like do a final touch up for it to make it look nicer aesthetically. And I guess it will also affect accuracy to some extent. Yeah. It's a curve, so the ends all have to be rather smooth. Yeah, so I'm smoothing out the outlook of the curve. Okay. Alright, so the curve will roughly look something like that. And what I'm going to do next is that I'm going to label the curve. Y equals to the graph, y equals to x squared minus 2x minus 1. Okay, don't forget to label all the time. So part 3 says, hence solve the equation for x squared minus 2x minus 1 equals to 0. Now the fact that it's equals to 0 means that y itself is equals to 0. So what happens when y is equals to 0? This is the point where y is equals to 0. Basically talking about the x-axis. So along the x-axis, what are the corresponding x values? that's what they are looking for. Okay, so I'm going to use red pen to indicate my response. Of course, in the exam and all your practices, you should be using pencil, but just for highlighting purposes, I'm using a red pen. So this is one of the solution to the question. Okay, and we can read off here that x is equals to minus 0.5. Yeah, and over here we can see that there is another intersection between the graph and the x-axis, and if we were to read off, this will be 2.35. Yep. So using the graph to solve the equation, this would be the answer.